Okay guys, now that we've gone through and discussed the different ways that we can write out reactions. Okay, so we've got word equations, just using words, skeleton equations, which are the chemical formulas, and then our best form, which was the previous lesson on balanced chemical equations. Now we can start talking about, well, what reactions are we actually going to write out? Okay, and there's not a lot of different types of reactions. There's actually only 5 of them. Okay? The first type we're going to go through today is combustion reactions. Okay, what we normally think about is fire. Okay? And when you think of fire and combustion, you're pretty accurate. Okay? So now that we know how to write out reactions 3 ways, okay, like I mentioned, we can begin applying our skill to actual reactions. So although there may seem to be millions and millions of different reactions, they can all be categorized just into 5 groups. And these are the 5 groups that we're going to go through while starting combustion today, and then next week the other ones. And the different reaction types are combustion, synthesis, decomposition, single displacement, and double displacement. Now today we're only going to focus on the first one, which happens to be the easiest, which is combustion reactions. Okay. So combustion reactions, we often think of these reactions as fire, and in most cases we are correct. Okay, there is a few examples where there's not actually a flame and it's still considered combustion, but when you think of flames and combustion together, they are most of the time the exact same. Okay. So combustion reactions are by far the simplest, and they're so simple because the reactants and the products follow certain rules. Other reactions don't really follow all kinds of different rules, and they aren't as simple as combustion, but combustion really has 3 rules. Okay? The first rule is that oxygen must always be a reactant. Okay? So if it is a combustion reaction, you're going to have oxygen as a reactant. Right? All combustion reactions. Okay? So every time you look for a combustion reaction, you better be able to find oxygen as a reactant. And that's a good indicator that it's combustion. Not for sure, but it's an indicator. Okay? Now, the second rule is that the other reactant almost always contains carbon and hydrogen. Okay? It has to have carbon and hydrogen in it. So it could be a bunch of different types of molecules, and they can have a variety of different molecules inside it, but it should have the atoms, carbon and hydrogen, somewhere in it. Okay? Almost everything that can burn, okay, that can actually form combustion, so it can light on fire, is full of carbon and hydrogen. There's a few examples, like magnesium ribbon is one that I gave you an example of in class, but most times it's going to be carbon-based. Okay? And then the last one is that the products under normal combustion are always the exact same. Water and CO2. Now, they're always not the same proportion. Okay, if we balance it, there might be more water or more carbon dioxide depending on what you burn. But every time you burn something, okay, this is very, very surprising. At least it was surprising to me. Every time you burn something, you're always producing 2 products: carbon dioxide and water. Okay, under good combustion. Okay, we'll talk about some good and bad combustion coming up. Okay. So let's go through each of these rules. So combustion reactions are by far the least of the simplest, and the first rule is that oxygen always must be a reactant. Okay, so here's some examples of combustion reactions, and we know they're combustion reactions because one, oxygen is always going to be in there. Okay, you're always going to have oxygen as one of the reactants, so reactants being on the left side. So that's a one telltale sign it's combustion. Now, it's not 100%, oh, there's oxygen in there, it must be combustion, but that's at least an indicator. Okay, now let's go to rule number 2. Okay. So along with having oxygen, okay, which is rule number 1, rule number 2 states that the other reactant must almost always contain carbon. So if we look, here's methane. So this is when you burn natural gas, okay, or methane, or CH4. Okay. Another fossil fuel, okay, C10H4, just a different number of carbons and hydrogens. Ethane, C2H4. Okay. All these different fuels that we burn, all these things we're going to burn with oxygen. Okay. Methane, ethane, propane, which is in our barbecues. Some people heat their homes with propane. Butane, which is in lighters. Okay. Pentane, octane, which is in gasoline. All of these are just carbon and hydrogen based. These are what we call fossil fuels or hydrocarbons, and the name tells it fine. They're made of carbon and hydrogens, and they burn really, really well. Okay. You can combine these with oxygen, and you're going to produce the products. Okay. And let's go to our last kind of rule here is number 3. Okay, the products are normally CO2 and H2O. Now, I put the word normally in there on purpose because we're going to talk about sometimes when it's not. But if you look, no matter what you're burning, it's always going to be the same product. Okay, whether I burn methane or naphthalene, ethane, propane, butane, whatever I burn, okay, it's always going to be, if I burn plastic, it's going to be this. If I burn oil, if I burn kerosene, if I burn paper, all it produces is CO2 and H2O under perfect combustion. Okay, but it's not always perfect combustion, okay? So what perfect combustion is this process, the one that I just highlighted, okay? You take methane, oxygen, CO2, and H2O, okay? But when you see a yellow flame, and most of the time we see fires, we see yellow flames, okay? That indicates that it's not perfect combustion, that you are not burning perfectly here. Whenever you see a yellow flame, what that indicates is that you don't have enough oxygen. Okay? You're not having enough oxygen to have a perfect burn. And if you don't have enough oxygen to have a perfect burn, then you can't always produce CO2. You'll produce it sometimes, but not all the times. And what you end up producing, okay, because you don't have enough oxygen, is something very dangerous. So let's just rewrite this. I've got CH4, and let's say I have low oxygen that I'm going to burn it with. Because I have low oxygen, I can't produce CO2. I don't have enough oxygen, so all I produce is CO. And this is very dangerous. This is carbon monoxide. Okay? And then I still produce my water. So this is a very, very dangerous gas, and it comes off whenever you see a yellow flame, which is why we should never have yellow flames inside. Okay, you should never have a yellow flame inside your house, because if you do, you're producing carbon monoxide, and that can build up and eventually poison your family and potentially kill them. Okay. Now, there is some exceptions, like a candle. Okay, if you have a few candles going, they're going to have yellow flames, but they're not going to produce high enough levels. But if you had 100 candles in your house, all burning, then you would be running a risk of carbon monoxide poisoning. Okay? Now, there's another thing that this can produce. Okay? Is what if we have really low oxygen levels? If we have such low oxygen levels, we won't even be able to produce carbon monoxide because it'll be so low. And what we'll produce is just pure carbon. And you've seen that before as soot. Okay? That's what soot is. All soot is 100% pure carbon. And what happened was that you burned it with not enough oxygen to produce CO2, not enough oxygen to produce CO, but just enough to produce carbon, just pure carbon. Okay? And that's what black soot is. Okay? So this yellow flame right here that I have left, this is what we call considered burning dirty. And we call it dirty because you're producing dangerous chemicals. You're producing soot, or pure carbon, and then carbon monoxide. Okay. So any flame burning inside must be blue, or you risk a carbon monoxide poisoning. And the exception is a small number of candles. So you should never have a fire inside that is yellow. Okay. Obviously, it's in a chimney, it's being ventilated out, but you should never have a barbecue inside. You should never have a bonfire inside. Okay. I'm hoping these things are obvious to you, but you never know. If I put it over my yellow flame, it will. Okay, because the yellow flame is producing pure carbon. Okay, now, when we get a blue flame, and if you remember, this is what we want to get when we get to a Bunsen burner. And why we wanted to get to a Bunsen burner? Because we are burning clean. When you see a blue flame, that means that you are burning clean. That means that you are only producing CO2 and water, and that is not dangerous. Okay? So when we light our Bunsen burners, they start off as yellow because we're not doing perfect combustion. We don't have the perfect amount of oxygen. But then we start turning the air valve, and that's why you're turning that air valve, is you're giving it more and more oxygen until you have just enough and it becomes blue. Okay, so when something has a blue flame, it's burning completely clear. It won't produce any soot. So if I put, say, a spoon over top of this flame, that spoon will not turn black with soot. And this flame is not. This is another reason why in Bunsen burners we don't want all of our glassware being covered in carbon or being covered in soot, so we make sure it burns blue. Okay, so this is the flame that you always want to see. You want to see a clean burning flame. So just some examples of some clean flames and dirty flames. So right here, this kind of picture that I have up here that I'm kind of highlighting, okay, this is your furnace. Okay, so if you have a gas furnace at home or a propane furnace, what it actually, I don't know if you've ever looked at it, but really what it is about 4 flames that are all burning inside. It's like 4 Bunsen burners going all at the same time. And then air travels over top of those flames that you have, heats up the air, and then it comes out your vents. So you're just basically heating up the air with fire. But notice the color of them. since your furnace is inside your house, you have to have it burn clean. Okay, and you need an apparatus to make things burn clean. If you just start a fire, you're not going to have the perfect amount of oxygen. So if I just light some paper on fire, it's going to burn orange. It's not going to burn clean. You have to have like an apparatus, like a furnace or a Bunsen burner, that gives it the perfect amount of oxygen to burn clean. So all furnaces should look like this. Now there is a chance that your furnace could accidentally switch from burning clean to burning dirty. And that's why we always suggest that you have a carbon monoxide detector right beside your furnace to detect whether your furnace had accidentally switched over to burning dirty. Because if it does and you don't detect it, your whole family could potentially die from carbon monoxide poisoning. Okay, because there's no smell or no taste to it. It's called the silent killer. Okay? This is another example that I have for you. Okay, over here, this is a stovetop burner. So if you have a gas stove or a propane stove, your burners should be burning blue. Okay, if they are burning yellow, it means they are not burning correctly. Okay, it means that they are not getting enough oxygen and you're actually producing some carbon monoxide. Okay, so these two things should be inside, and anything that's inside should have a blue flame. Okay, now it costs a lot more to make a blue flame, which is why we don't always have blue flames, like your barbecue. Okay, your barbecue is supposed to be meant to be burned outside, so you don't need to have a perfect blue flame. You can have orange flames or yellow flames. Now, if you get a very, very high-end barbecue, it will burn blue. Okay, because you've paid so much money. That money went somewhere. It went to making sure the flame was blue. But kind of our lower end barbecues, they burn yellow. Okay, or if you just start a fire like here, it's going to burn yellow. So burning dirty, producing carbon monoxide and soot. Okay. All right, so that's our first kind of introduction on combustion. Again, if you have any questions, you can email me.